Hello and welcome to another tutorial. So this time we're going to be focusing a bit more on the C# side of things, and we're going to be taking a look at two things, System.Func and System.Action. So the two things that we've got access to in Unity, and they allow us to do some kind of neat little tricks that can be really handy. So let's dive on in. And what I'm going to look at first is System.Action. And what I'll do is I'll just create a folder here for our scripts. It's not really anything we're going to be focusing on in the scene. So it's more about being able to have just some basic script logic running. Demo logic. And I'm just going to, once it's compiled our scripts, throw this onto, just throw this onto the, actually I will create a cube. So we might do some stuff with movement, but we'll put the script onto that. So, okay, we're going to take a look at System.Action first. So System.Action and Unity Action are quite similar. They provide same sort of functionality largely. Unity Action is more if you're doing stuff where you might need things adjustable in the inspector, configurable there, then you would use that. Whereas System.Action can be really handy for just baseline stuff that's sitting in pure sort of C# code. Performance-wise, seem to be much of a muchness. From testing that I've seen done, there's the tiniest performance difference with System.Action of it being a little bit faster, but the difference is so tiny that it's effectively not there. So I would say generally what I would do is I use Unity Action when I've got stuff that's being exposed in the inspector, and I use System.Action when I've got stuff that it's happening just in pure C# code, in particular if I might want to be adapting that to being used in other things. So the idea behind it is I can go System.Action, and then in its simplest, I could do something like this. Demo action 1. And then what I could do, demo function 1, and we'll just have this to a debug log. So we have it outputting this, and then what I would do in start is I can do demo action 1 is equal to demo function 1, and then I can just go, well, demo action 1 invoke. So very similar to what we could do with a Unity action. And if I run this, what I'm expecting to see is that it's outputting demo function 1. So let's go and run it, and we see that it does. Now, okay, where this starts to get really handy and really useful is some more intricate things that we can do. So let's say we want this where, okay, I'm going to have an enum here. And we might just call this movement direction or movement mode. And what I'm going to do here is I might have bounce and rotate. And then I'm going to create something that's going to seem potentially a little bit weird, of a dictionary that the key is going to be the movement mode, and it's going to take in a system action. So movement functions, like that. And then what I will do down here is movement functions. We'll firstly new that so it's properly set up. And then I'm going to have void move bounce. And then I'll have a void move rotate. And what I could do is then here go, well, movement functions, movement mode dot bounce is equal to move bounce, and rotate is equal to move rotate. So we've got a dictionary that what we're storing in that is based upon some key. Here is a particular function to run. So then in update, I don't need to go and do anything further. I can set up here, have a public movement mode. What I would do here is movement functions, movement mode, invoke. And then what these do is, okay, well, there's a couple of little bits of stuff we obviously need to do where we store position, where we store our, we don't need to store the initial rotation, which is fine. But what I would be doing is initial position is that. What we'll do is we'll do a mathf sign time.time, and could just use directly that, but let's multiply that by pi. So now when 1 second has elapsed, it will have completed half of a cycle. When 2 seconds have elapsed, it'll have completed a full cycle. So it'll go up and down over the course of 2 seconds. And what I will do is just go transform position as our initial position plus vector 3 up multiplied by that. For rotate, we can just go transform and we'll do a rotate, and we'll just use the version where we provide the individual amounts, and we'll just go 0, 0, and let's go 30 times by time dot delta time. So that's good. What it should mean is that we have something where when we change that setting on this, it'll move different ways. So we can run this. We should see initially that it's bouncing. If I switch it to rotate, then it changes to now it's rotating. So it saves us having to use if statements or a switch, stuff like that. Allows us to look things up in a map, which if we've got a lot of things that need to happen, this can actually be a really efficient way of doing that. So it allows us to run a different function based upon the data with much less code and much less process for sort of setting it up. So you could imagine, you could have this based like depending upon what you're doing, different things based upon different items you might have, different stuff based upon different effects that might be in place. Makes it really easy for doing this. So what if we wanted information passed in? What if I wanted the delta time to actually be directly passed in here? Just in case there might be some scaling that I'm doing, so I don't want to use the global delta time, which is not uncommon. So as soon as I do that, well, we'll get errors here. This is not yet giving us an error, but here is because we haven't told it that these system actions can take a parameter. So what I have to do is do that. So our system actions can take in multiple parameters. We can actually have quite a few parameters provided there. And it just changes how we structure this. So System.Action can take in different parameters. We can bind it to different things. We can rebind it. We could check, maybe this isn't supported in some movement modes. So I could be checking, if movement functions contains, firstly, that movement mode, and just, as an extra check, that movement functions movement mode is not equal to null. Because system actions can actually be null, which again can be really handy, that you can have some things hooked up and some things not. So it gives us a way of being able to have that custom logic happening for things. So I use system actions quite a bit when I'm setting up things. They're a really handy way of being able to have callbacks, things like of that. One of the limitations, though, with System.Action is there's no way to have it return something. So if we want to have it actually return something, this is where we use System.Func instead. Okay, so I'm going to set up a System.Func. So we have System.Func demo, daemon. Now what you'll notice is I get an error. We have to provide a return type here. So what if I just provide void? So you'll notice that is not valid. It has to actually be a returnable type. So it has to actually be a concrete thing. We can't just use void. So I could say float, and that will be fine. And then what I could do here, then I'll just return a random range from, say, from 1 to 12. One of the things with this is if it's gone and added in system, like of that can actually cause it to have issues with knowing which random it's talking to. So, and sometimes Visual Studio will be helpful, and just automatically add that in. So that's something just to watch for. So in this case, I can go demo func1 is a demo function 2, and then I can invoke that. Now I don't need to do anything with that return value, but I can. So if we just log that out, we should see we get that particular value output. Get our random value showing up there, so that's good. So Func is able to return data. It can also take in parameters. So for example, I could have a System.Func that takes in a float, that returns a float, but takes in 2 integers. And what this could do is this could be demo function 3, min value, max value, and then it returns a random float between those. So that would allow me to then have demo func2 is demo function 3, like that. And then I can do the same sort of thing where what I do is I invoke it, and I give it 1 to 100. You'll notice we're getting an error with this where it's saying it doesn't match. That's because, an important thing, the return value is always last with a func. So return value always listed last for it. Parameters go before it. But if we run this, we'll see that it's able to run the particular logic. And we can see we get that output. So, okay, really handy there with func and action for being able to set up things that we can bind to. But there's actually another way that we can set up these functions. And that makes it really sort of handy if we don't want to necessarily have an entirely separate function like this, which we don't necessarily want that in all cases. So what I could do is I could set up another movement mode here, and let's call this bounce and rotate. That. Now for it, okay, well, movement functions, bounce and rotate. So I don't want to set up an entirely separate function for it. What I could do is I can create what's called an anonymous function, like this. And so what this is going to do is it needs to take in a float. So float delta time, like that. And then what I can do is I can steal the logic from both of these, because it's already doing what I want it to. So both of these, take one as well. So we can just set up the function in line like this. So this can be really handy. I use this quite a bit for example, with AIs, if it's a case of, cool, okay, you want the AI to go to a location, and when it's there, it does a particular thing. This is a handy way of you can have it so that you have the go-to function be able to be given a System.Action, or it might be a System.Func, that it runs when it reaches the destination. You could also give it a failure one that it runs as well. So having these setups for being able to define these little functions like this is really, really handy. So what I can then do is I'll just see if I switch this to bounce and rotate and run it, I should find I get the exact same stuff it runs. So it's good. I could switch it back just to bouncing, or to rotating, or again to both. So, okay, we can define our functions in line like this. They can take in parameters. They can access local variables that they have access to. Really, really handy method for being able to do particular stuff. And as I said, a common usage of this is telling something, okay, go to this location and then do something else. So I'm going to set up a version of that. So we're going to create a demo logic 2, and we're going to create a sphere. And I'll illustrate how we could do something like of this. So demo logic 2, what I want to have for that is, okay, we're going to give it a transform for start point, a public transform for end point, and a float for movement speed. We'll say is 2. Okay, I want to have the transform that we're moving towards, so target transform. And then in update, I want to go and say, okay, transform position is a vector3 move towards. We want to be able to say, okay, well, here's our transform position. Here is our target transform position, and the speed by time.delta time. And then I want to check if we're largely there, which I'll do that actually beforehand. So what I can do is I can go, okay, well, transform.position minus our target transform position. If the square magnitude of that is less than float epsilon, then we know we are at the target location. So, okay, we'll do something when we get to the target location. So what I can then do is I'm going to have a system action here for reached target. We'll invoke that here. And then what I could do is have a void MoveTo, takes in a transform, and that's the new target. And then it also takes in a System.Action for on reached target. And then all I do is target transform is our new target, and reached target is our on reached target, like that. So then in start, we can go MoveTo, and then what it will do is we'll initially move to the start point. Then, on reaching the target, what we can say is it's going to be a return to random.value. Random value is less than 0.5. Then it's going to be the start point. Otherwise, it'll be the end point. So we just randomly pick a particular location to head towards. So we don't actually need to do a return. We just do target transform as that. So it'll always move to it. And when it gets to a location, it will just pick the next transform to head towards. So, okay. Let's see how this behaves. I can grab the sphere here. Now, what I'm going to do is move the game view down there. And then I'm going to create a couple of objects. This will be target 1. We'll move that here. And then we'll have another 3D object. And this will be target 2. That will position here. And then we just link this up to the sphere. So it'll initially head to target 1. And then what we may find is it will then head to target 2. Depends on what it will roll. We run this. So we can see it moves to that. Then moves to this one. Once it gets there, it should hopefully randomly pick to go to that one. So we could have multiple targets that it's picking between as well. But the main thing is we've got this handy little interface where we can say, okay, move to this location, and when you get there, here's some logic to run. So really, really handy for doing stuff like that. That's the main use case that I have for generally when I'm using System.Func or System.Action is stuff like this where it's, okay, go and do this thing, and when you're done doing it, here's the logic to run. Or this setup where we have a map of particular things. Could also be a list of ones, depends upon what you're particularly working with, but being able to store a set of functions or a set of actions, being able to pass them around like this is really, really handy. It allows us to structure our code better, and in particular, being able to do inline ones like this. Now, I wouldn't do an inline one like this if it was pages and pages and pages of code. I would try and keep it to be a fairly short amount of code, just because readability can get a little bit difficult if you do have too much code there. But being able to do little inline ones like this can be really handy as a way of just simple little bindings there. You'll see a similar approach used a lot in user interfaces, but generally really handy way of structuring your code. So this is something to think about in terms of if you've got something where, so the two main use cases I would say to look for in your code where you might want to use this is if you have it where, okay, something is happening over time, and at the end of it, here's a particular bit of logic that you want to have happen. Or if you have a case where you're got multiple different things that it could do, and you want to easily be able to switch between them. So you've got multiple functions that are being called, and we might normally have an if or a switch statement, something like that. This is a case where you can use System.Func, System.Action as a way to handily be able to do that sort of logic. But dive on in and experiment with it. See the kinds of things where you could be making use of that. See the kinds of things that you're in your own code that might be a handy adaptation of that. Experiment with adding in ones like these little anonymous functions. Experiment with doing ones where you're grabbing variables and seeing the way that that works. Thanks folks, hope you found the video interesting and helpful. If you have, chuck in a like and subscribe, really helps out, it's really appreciated. If you have any questions, chuck in a comment below. If you're looking for the code for the project, the code is available up on GitHub. There's a link to that in the description, and you can use the code in any of your own projects, commercial and non-commercial ones. If you are trying to track down other videos, I do have a searchable video archive, so that is linked in the description as well. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description also. But until next time,